both. We'll cover both
Both
SQL and
DynamoDB.
NoSQL, even how to create DynamoDB, how to insert that records, and then how to query it. All that we see it in today's session. Okay, and also we do
Okay.
a simple automations, how to connect it to RDS using a Boto3 automation, and how to connect it to DynamoDB using Boto3 automation. We are going to see all that in today's session. Okay,
Yeah.
you got it right there.
Yeah.
Right. So now let's start that. So today's topic, I'm going to start with this one, relational databases, connecting to the databases, not just relational, connecting to the databases. And we see how to connect it to relational databases from AWS, how to set up relational databases, and how to connect it to those databases, and then how to create tables and then insert records and then query records. We are going to see all that. And similarly, we also see the same for NoSQL databases. And also, like we also see how to connect to NoSQL databases, how to set up NoSQL database in AWS, and then how to insert data and then how to query it and check all the details. So that is what today's session is all about. So let's focus on that. So the focus area is this for today. What is the focus area? I'm going to talk about these topics today. So where is the syllabus? I put syllabus somewhere. Okay. The whole topic list, I put it in one place. I'll just show you. See, yeah, phase 4 databases. And then in that, we are going to talk about relational databases, that too RDS. Okay. And then this is the service, of course. And then we see how to set up MySQL and work on a bit of MySQL thing. Similarly, we will also discuss NoSQL basics, and that too we see that how to work with DynamoDB, how to create table in DynamoDB and insert records and do all this details in DynamoDB. Okay, so now to connect it to any database, suppose let me just use a paint here. So generally we know there are two types of things in development. What is that? Suppose we have something called so on-premises databases, right? And in this on-premises databases, generally we have two types of on-premises databases. Okay, let me just go one by one. I'm going little detailing into this, okay, so that it helps you to get a bit bigger idea in this on this. Okay, so what is that? The first one, we have relational databases. Okay, relational databases. The second one, we have NoSQL databases. NoSQL databases. So I'm not going too deep into this discussion, this relational or NoSQL databases, but I'll give a very quick idea about what is relational, what is NoSQL, and what are different NoSQL databases available. What are different relational databases available, popular relational databases, and popular NoSQL databases. Okay, let's quickly have that idea. So now I'm just going through this thing. Okay. So generally relational databases are used to store structured data, right? Data which is in structured format, like employee information, customer information, course information, student information. All such details we generally store into relational databases. And usually NoSQL databases are used to store unstructured data or semi-structured data like JSON, like Excel, like CSVs, or like audio, video, images. Such kind of data, we can store it in NoSQL databases. Okay, so this is the quick idea. If structured data, you can use any relational databases to store such data. If unstructured or semi-structured data, we try to store into NoSQL or what is that? This not only SQL databases. Got it? So now let me just quickly walk through these things. Okay. So what is a relational database? So generally, what is that? It is a database, a relational database stored data in tables in the form of rows and columns. with relationships between them. And here each row is one record and each column is one field. Okay, that's how. And we create tables like this. So this session is not about creating data. I mean, this is not a DBMS session or database session, but just quickly showing. And this is how we create tables, right? Next one. And in AWS, how do we set up a database in cloud computing in a cloud environment like AWS? How do we set up a database? And then how do we try to do operations and manage those databases like creating tables, inserting records, updating records, and then selecting that data, searching for that information, all that. So for that, we have a service in AWS to connect to relational databases. And that service is called Amazon RDS. And this Amazon RDS is exclusively to connect to relational databases, not to non-relational or NoSQL databases. So what is RDS here? It is a managed service by AWS that makes it easy to set up, operate, scale relational databases in the cloud. Especially this Amazon RDS is exclusively applicable for setting up or to set up, operate, and scale relational databases in the cloud. And it supports all these database engines. Okay, like MySQL, PostgreSQL, MariaDB, Oracle, SQL Server, Aurora. Like it helps to set up all these supported engines. Please go on mute if someone is speaking. Please go on mute, please. Okay. Or
Manohar, you can mute all of them.
yeah, I'm doing. Okay, and then so please mute your machines when you join the session so that it helps us not to interrupt. Okay. So shall I share my screen now? Am I in sharing? Yeah, I muted it.
Yeah, you are sharing.
So these are all different database engines supported by this RDS service in the AWS. Okay, now key benefits. What are the benefits if you are using this Amazon RDS to set up your relational databases and manage them? The key benefits are you have automated backups and your databases are highly available, and also scaling rates. It will do auto scaling, depends on need and necessity, and auto patching and monitoring. It also helps you to do auto patching. If any updates are needed, it will automatically apply those updates. And also monitoring. It's easy for us to do any monitoring in cloud platforms or cloud environments. So these are the benefits what we have when you are using Amazon RDS, the service Amazon RDS. Okay. And now this is a quick comparison between MySQL and Postgre. Okay. So if you want to just go with some lightweight databases, which are open source, so and start with something, then MySQL and PostgreSQLs are best choice for us. And these are basic quick differences between these two. Okay. Of course, we have we also have a comparison table for all other database engines. We'll just quickly go through that. You can see here, right? So what is that? If it is MySQL, the feature is MySQL, PostgreSQL, popularity. MySQL is very widely used and PostgreSQL is growing fast, open source. Both are open source. That's why we are having a comparison here. JSON support. It's basic. Generally, MySQL supports basic JSON support, whereas PostgreSQL supports advanced JSON functions. Okay. Performance-wise, MySQL is good, but whereas performance-wise, it's strong for complex queries. PostgreSQL is strong for complex queries. Use case. Generally, we use MySQL if you are trying to set up web apps or e-commerce applications. Suppose If it is PostgreSQL, if you want to do any data analytics or enterprise apps, then PostgreSQL is best fit. So based on this, you can choose which one you want to set up, either MySQL or PostgreSQL. Okay, and both are open source, and it's up to you which one you want to choose. Okay, next after that. So this is a quick idea about RDBMS and then Amazon RDS service. Okay, now we are switching to the other part of this other side of databases, that is NoSQL databases. NoSQL is called not only SQL. Unlike relational databases, we don't generally this NoSQL doesn't store structured data. Okay, unlike relational databases, you can see here, NoSQL databases don't use tables or fixed schemas. Okay, also generally we don't, for storing structured data, we use this relational databases. If you want to store semi-structured or unstructured data, we use NoSQL databases. Okay, and these are designed for scalability, low latency, and flexible scale. Okay, and generally for this big data applications, data engineering applications, and this data science applications, data analytic applications, all this kind of applications uses this NoSQL databases. Reason we will discuss that. We are going to talk about it. But this is the quick idea. Like what is NoSQL means? It's not only SQL. Like if it is relational databases, they have fixed table structures and fixed schemas. But whereas for NoSQL, generally we don't use tables or fixed schemas here. They are designed for something called scalability, where data keeps coming and that even table columns also might keep growing. And if you have any latency issues, to fix that issues means the speed of retrieving data or storing data. If you have such issues with data, then even to fix such issues, this NoSQL databases are helpful. And a flexible schema, your schema can be increased or decreased, right? We don't have a fixed schema in NoSQL databases. If you add data, the schema increases. If you insert columns, you can add more columns to the schema, or we can remove columns from the schema. And based on that, the schema is flexible. Okay, we can dynamically add columns, we can dynamically remove columns. So that is the advantage with NoSQL. Okay, and here in AWS, the NoSQL DB which we are using is Amazon DynamoDB, right? And this is fully managed NoSQL database service by AWS. So if you want to have a NoSQL database in AWS, then definitely DynamoDB is the best choice. And it provides fast and predictable performance with seamless scalability. Okay, you can have in simple, you can have speed and best performance with the DynamoDB. And the key concepts here. We have tables, nothing but collection of items, right? Nothing but collection of items in sense, collection of columns. Item is a single record, like a row. Attributes are nothing but key and value pairs, like columns. Okay, primary key. You must have a unique primary key, which is nothing but unique identifier, which is specified with partition key or partition plus sorted key. We are going to see all this in today's session, right? With a practical step-by-step instructions, we are going to apply all this. Okay, this is a quick idea about DynamoDB. Are you following, friends? So only thing is I just need to check. Yeah, we are recording it. And then after that, so this is about NoSQL Dynamo. So what is NoSQL database, and then what is DynamoDB? This is DynamoDB is a service which is provided in AWS to set up and work with NoSQL database. And here DynamoDB itself is a NoSQL database, and that is also provided as a service in AWS. Okay, you got it right. So that's the idea. Next one. So this is how generally a record look like in NoSQL databases. Record in sense nothing but NoSQL databases generally stores data in the form of JSON records. Right? You can see that this JSON data you can insert into the DynamoDB, and this acts as one record. Likewise, you can change student ID, name of that course, and then name of that student, and then course. You can change that score. You can change that all that information. Likewise, you can change the data of each of these columns, and then you can insert again as one more row. So likewise, you can insert how many of rows or records you want into a NoSQL database. But here, each JSON you can see here, right? This one represents one record. Okay. Now after that, and these are the features of DynamoDB. What are the features of DynamoDB? These are serverless. No need to manage infrastructure because this is in cloud, AWS cloud. It is automatically managed by AWS itself. Automatic scaling for read or write capacity. So here you suppose if you have more data, automatically it increases the capacity of that database. If you have less data, it decreases the capacity of that database. That auto scaling capacity is there. We can set it up, of course, so that we don't need to worry about the amount of data coming from different sources. Okay, this helps us to leverage that the size of or volume of data that is coming, and global tables for multiple region replications. Okay, replication is something keeping a copy of same existing data so that if any issues happen, so that replicated copy helps us again as a backup. So that's the what is replication in a just and short this thing discussion. Okay, DynamoDB accelerator for caching information. Okay, and then streams for event-driven applications. These are the features. We can go a little deep into that when we have a very detailed discussion on DynamoDB. But these are the features. Okay, whenever we go with DynamoDB, what are the features in sense? It's serverless, automatic scaling, and it has global tables for multiple regions and replications. And it has DynamoDB accelerated, which is called DAX, for caching all that data. So that when you know, right, what is the need for caching? It increases the service, or it avoids latency issues. Okay. And streams for event driven applications. Suppose you have some webcam trying to capture live data. Okay, or otherwise, likewise, there are different other scenarios where we try to capture the streaming information. So to handle that, there is a feature called streams to take care of such kind of event driven applications. So, and when this is ideal, when this DynamoDB is recommended, it is real time. It is recommended for real time applications, like like if you want to store this real time in sense like cricket information. Okay, game is happening. You want to just keep track of all that score and everything. That is a real time data. And similarly, you take any flights, even that is real time data because right, that scheduling, departure, arrival, all that is a real time happening time to time. Okay, and this is also helpful for IoT, gaming leadership boards, e-commerce cards, and in many places we can choose this DynamoDB. So this is the advantage of that. Okay, next after that, and now you can see that differences between your traditional RDS and then DynamoDB. RDS is a service where it helps us to set up different database engines. RDS itself is not database. Okay, relational database service. RDS means relational database service. And in that service, we can set up any of these databases. Using that service, we can create or set up any of these database engines like MySQL or Oracle or SQL Server, or there are 7 or 8 database engines. We can set up any of those relational database engines under RDS. Okay, and these are the features. What is that? Feature is either RDS in under RDS or Aurora. We can name it as Aurora. Okay, that is the feature, and DynamoDB is for NoSQL, and for relational we have RDS and Aurora. Okay, and we can set up what kind of databases here under relational, MySQL, Oracle, SQL Server, PostgreSQL, likewise, and MariaDB, and one or two more databases are there. And in DynamoDB, it's DynamoDB itself. That itself is a service plus that itself is a database. And type. Here, if you see, RDS supports relational databases. Even Aurora supports relational AWS optimized databases. Okay, and then DynamoDB supports NoSQL. Okay, so so far we had a very detailed discussion. And query language, RDS supports SQL, Aurora supports SQL, and DynamoDB supports nothing but key value API. What is that key value API? Again, if you just see here, right? If you see this JSON data, and here each field here, right, is represented as key and value pair, and that is what key value pair in NoSQL. The data inside NoSQL is stored as in the data in the form of key and value pairs, and collection of key value pairs will form one record, and group of such records will create we can say that a table. Okay, we can have so many records like that. Okay, we'll go more detailed into that, but this is the quick idea. What is key value instance? So you just, I think by looking at this, you'll get a clear idea. This is nothing but storing in the form of key and value like this. Okay. Now after that, schema. For RDS, we have a fixed schema. Even Aurora uses fixed schema, whereas for DynamoDB, it has to be flexible. Okay, because based on number of columns, number of key values you are inserting into the table, that column length has to change. So that is why DynamoDB, that schema is flexible or dynamic, right? So that is the idea. Scaling. So we have vertical plus read replicas. That is the scaling applied here. We'll talk more on this little later. We don't need to pitch in again or deviate from our actual discussion. And Aurora uses auto plus replicas. And this uses horizontal. Okay. Horizontal in sense, suppose so you see as data keep coming, so you need to add more machines. So that is automatically done by this cluster, Dynamo cluster. So that kind of scaling is called horizontal scaling. Vertical scaling means in the same machine, if you increase the hard disk capacity or RAM capacity, that is called vertical scaling. Horizontal scaling means you have not just one machine. Suppose if one machine is completely full, you try to put data into that, distribute that data into another machine and into another machine and to another machine. That's keep on adding that machines into the cluster, right? As and when data is growing, you just keep add a node to the cluster and a machine to a cluster. And such thing is called horizontal scaling. And that is what happens with the NoSQL databases. Somebody asked me a question yesterday, right? When to choose NoSQL, when to choose relational. If your data is, you cannot predict how much data is coming. And if you want your database to be horizontally scalable or distributed, in such cases, generally we prefer this NoSQL databases, and DynamoDB one such database. Similarly, we have MongoDB, we have HBase, like Cassandra. There are so many NoSQL databases that exist in the market. Okay, so this is the difference. I mean, how the scaling is done. And use case. Generally, for traditional applications, we use this relational databases, and then we try to set up with RDS service. For high performance apps, we choose Aurora. And for real-time applications, all real-time data, right? So all that data coming from different social media applications, we can treat that as real-time apps. Okay, for such kind of requirements, DynamoDB is best fit. For traditional needs, like where data is fixed, right, and then structured, in such cases, we prefer this RDS and Aurora relational databases. Okay, so this is overall quick difference between what is RDS and what is Aurora and Dynamo. Aurora and RDS almost they are under the same bucket. Okay, almost they are almost similar, except here and there are a few differences. That's all. Okay, now after that, so this is the difference between SQL and NoSQL. As before I jump into the actual setup and show you a few examples, what is the difference between SQL and NoSQL, right? So you can see here features SQL database and NoSQL database full form. SQL is structured query language. NoSQL is not only SQL. Type SQL is relational database, whereas NoSQL is non-relational or distributed database. Data storage. Here, data is stored in the form of tables, in the form of rows and columns in SQL databases. Whereas the data stored in NoSQL, it is stored in the form of key and value base or in the form of documents or wide columns or graphs. We just have seen all that, and we will also see with some examples in today's session. And the schema for relational databases, schema is fixed. Okay, you must define columns before inserting data, like saying select. You can see that create table, table name, that columns information. Whereas we have flexible schema for NoSQL. NoSQL uses flexible schema, right? You can add new fields anytime. We don't have issue with that. Query language, we use SQL for SQL database. Whereas for NoSQL, we use something like APIs or JSON-like queries. Okay, it depends on, again, NoSQL database. For HBase, we use something called HQL, something. Similarly, it depends again. Okay. Similarly, data relationships. Here, relational database supports complex joins, combine data from multiple tables. So generally in NoSQL database, we don't have any joins, no joins, uses nested data instead. Okay, instead of joins, we have data, I mean that block inside a block. That's called nested data. Okay, or JSON inside a JSON, that is called nested JSON, something like that. And if you have data like that, it's called nested data. Okay, so we don't have joins, and that joins are managed in the form of nested data or nested JSONs. You got it right, something like that. Scaling. Generally in SQL or relational databases, we have vertical scaling. Vertical scaling means to the same machine, you can increase the capacity of hard disk or RAM or any other something in the same machine. Okay, suppose you have a laptop and that laptop capacity is it has a RAM capacity of 16 GB. Now you increase that RAM capacity to 32 GB. That's called vertical scaling. Suppose your hard disk capacity is 1 TB. Now you are adding 1 more TB additional extra hard disk to the laptop, to the same laptop. That's called vertical scaling. Understood? Horizontal scaling. You can add more servers easily. Suppose my laptop is completely loaded and it's completely occupied. It's full. Now I don't want to add anything additional to this, but I purchase one more laptop and add it to my cluster. That is nothing but horizontal scaling. Okay. So horizontal scaling in sense, add more servers to your cluster. So that's what. So that is done for NoSQL databases. And transactions. Generally here, SQL or relational databases follow ACID. What is that? Atomicity, consistency, isolation, durability, ACID properties. Okay. And for NoSQL databases, the transaction, it applies something called base, basically available. Means it should be available always. Okay, soft state, eventual consistency. Okay, these are the 3 basic qualities a NoSQL database must follow. Okay, and anyhow, you can explore it a bit later. I'm just only giving you a quick comparison between SQL databases and NoSQL databases. And examples, these are all different examples for SQL databases, MySQL, Oracle, SQL Server, PostgreSQL. These are all examples. For NoSQL databases, DynamoDB, MongoDB, Cassandra, CouchDB, there are so many like this. These are all examples for NoSQL databases. Which is best? When SQL database is best? for banking, ERP, CRM, and structured data systems. In all such places, SQL databases are best fit. For real-time apps, IoT, social media, unstructured or semi-structured data, NoSQL databases are best fit. So this whole slide is going to give a very detailed description between both SQL and NoSQL databases. I hope this gives you a deeper insight of what is the difference between SQL and NoSQL, when to choose SQL, when to choose NoSQL. Is that clear to all of you, friends? Before I jump to the next thing, before I jump to the another important slide, when to choose SQL versus NoSQL. So far, we have discussed the differences between SQL and NoSQL. But this slide talks about when to choose SQL and versus NoSQL. Is this clear for you? Till this, are we good? Are you good here? Harish?
Yeah.
And then Ajay and Simha, all of you are fine with that? Okay, then let me just move to the next slide. So this is another question yesterday we had in yesterday's class. When to choose SQL versus NoSQL. Okay. So SQL in sense when to choose relational databases. So when the data structure, when the data you are trying to store, when your data is structured and predictable, how much data is coming, what is the volume of data coming. In such cases, we choose SQL. Okay. So generally, when your data is unstructured, semi-structured, or changing frequently, means the volume keep coming, and you don't know how much it is coming. In such cases, generally we prefer NoSQL. And also, if your schema also keep changing consistently, continuously, then in such cases we prefer NoSQL. Okay. Another scenario: schema changes. When your schema is stable and doesn't change often, in such cases, you choose relational databases. When you choose NoSQL, when you need flexibility to add new fields anytime, dynamically, if you want to add columns or remove columns, in such cases, we choose NoSQL. And data relationships. When you need joins, foreign keys or transactions, in such cases, we choose relational databases. Suppose when relationships are minimal or embedded in one record. Embedded means a record inside a record, which is nothing but like nested JSONs. That is the best example. If your data is like that, in such cases, we choose NoSQL. Okay. Scaling needs. When you scale vertically, means if you want to add more hard disk to the same machine or more RAM to the same machine, when you want such kind of scalability, generally you prefer relational databases. So add more power to one server, you can see that is clearly specified here. When to choose NoSQL? If you need horizontal scaling, distributed data across many servers, not just you don't want to keep your data in only one machine or one server, but you want to distribute it to many machines and you want to execute them parallelly or do something like that in a distributed approach. Then we prefer NoSQL databases. Okay, consistency. When strong consistency is critical, like banking, payments, etc., we prefer SQL databases. When eventual consistency means not immediately you expect consistency, but over a period of time if you are expecting consistency, in such cases, what is that? You prefer NoSQL. You can see social media feeds, IoT data. When you are dealing with such kind of data, you prefer this NoSQL. Data volume. When data is moderate and relational, you prefer SQL databases. When data is massive and high velocity, that data is generating with huge speed, like the best example, YouTube or Facebook or all this social media, this thing, like WhatsApp. For these kind of needs, definitely NoSQL databases are very much in place, are very much helpful. Okay. And query flexibility. When you need complex queries or analytics, in such cases, prefer SQL databases. And here, for when you need fast keyed basis lookups or document queries. Okay, in such cases, for base systems generally, in such cases, we prefer this thing, NoSQL databases. Transaction type. If it is ACID transactions, prefer SQL. If it is base transactions, prefer NoSQL. So these are all the differences. This gives you a clear idea when to choose what kind of databases by having a clear this thing on this slide. Okay, we are very clear now. Just if someone has structured data and if you want to have a fixed schema, right? And if you anticipate how much data is coming, in such cases, we prefer relational databases. And in case of NoSQL, you have huge or massive amount of data coming. And if you want to have a flexibility to schema where you can add columns anytime or remove columns. Also, you want to handle latency issues, right? With that huge and massive data to target all these kind of parameters. NoSQL data is the best fit. So for all these big data applications, definitely NoSQL is in place. People, I mean, industry prefers NoSQL databases. Just keep that in mind, friends. Of course, they generally follow hybrid model. They have relational plus NoSQL in place. Just keep that in. Okay. Anyhow, this is only just to give a quick idea. But if you go to the real time, in real time, they try to have a hybrid kind of database structure where they try to have SQL plus NoSQL, and that is integrated as a hybrid model. And how they do all that is something. It's part of database administration. Let's not go too deep into that as of now because we are in cloud thing. As of now, this discussion is more related to the database, not to the cloud. So next, finally, because yesterday we have few questions related to the data and databases, so that I just added few more information so that if anybody has such questions, so this will help to answer such questions. Okay. So choose SQL when to choose SQL. Just final summary here. You can see here. If you are building a banking or ERP or e-commerce system, and you need a data integrity and a multi-table relationships, and schema rarely changes. In such cases, you generally prefer what is that SQL databases. And for that, we use Amazon RDS service for creating this relational databases. Okay. Choose NoSQL when if you are building real-time, large-scale or dynamic applications, and you handle unstructured data like JSON, logs, sensor data, or more. Okay. You need massive scale or low latency. Massive scale means if you want to store huge amount of data, and for that you need to have a horizontal scaling. Like if you want, you should be able to add more servers to the cluster dynamically. So that should happen automatically. In such cases, we prefer NoSQL databases. Also, you should also be able to avoid that speed issues. Low latency means which is nothing but it's a speed issue. So to avoid such issues, NoSQL is the best fit and it is recommended. And examples, DynamoDB, MongoDB, Cassandra, all this. You got it right. So finally, rule of thumb, SQL. When do you prefer SQL databases? If data is structured and reliable. When do you prefer NoSQL? If data is scalable and flexible. Scalable means you have more data and if you want to have a flexible schema. In such cases, prefer NoSQL. So this is a quick summary of when to choose SQL, when to choose NoSQL. So next after that, finally, again there is one more last slide before I jump to the practical part of this Amazon RDS and Aurora. Okay, when to choose different SQL databases. You can see here MySQL. Generally MySQL is just used for basic applications, right? And it's open source and free of cost. Best used when you need a free open source and reliable relational database for web or small enterprise apps. Okay, for a decent small companies and for any small kind of web applications like for learning, right, all these learning institutes or learning, I mean, edutech companies for such kind of this thing. I mean, enterprises generally basic needs, we can choose MySQL. Okay, key strengths. What is the key strengths of MySQL? It is easy to use, great community support, works well with PHP, Python, and Java. I don't have nothing more to go deep into that. That is a very straightforward explanation. Okay. And typical use cases. Generally, it is used to build web apps, startups, okay, WordPress applications, small e-commerce applications too. So these are the typical use cases where we use this MySQL databases. You got it right. This should give you a clear idea when to choose which database, which SQL database. If it is relational again, in that relational database, when should I prefer MySQL or PostgreSQL or Oracle or any of these relational databases? So this slide gives you that idea. PostgreSQL. If you need an open source, even PostgreSQL is also an open source database, but enterprise grade database with advanced features. You want to have a bit more advanced features compared to MySQL. In such cases, you can prefer PostgreSQL. And it is powerful, it has powerful SQL plus JSON kind of this thing. Okay, you can play around with both SQL thing and JSON. Extensible, supports geospatial. That is one more. So you can check that. What is that PostGIS? You can just check it later. Okay. And it has high performance for complex queries. So these are the important key strengths of this PostgreSQL. And generally typical use cases where we choose PostgreSQL, analytics, data warehousing, fintech, enterprise applications. In such places, we prefer PostgreSQL. Oracle database, right? When you need high-end enterprise performance, scalability, and security. In such cases, you prefer Oracle databases. And generally, Oracle provides high security, advanced security, strong transaction support, excellent for very large systems. Like, like if you want, like many big companies, like banking domains, especially like JP Morgan or Morgan Stanley, Bank of America, there are so many big companies, big banks. So for such banks, generally this Oracle database is best fit. Okay. You can see that banking, ERP, telecom, mission critical enterprises, like, a best example is mission critical instance. This, we can see that, right? Mm, this sharp, this rocket lines applications for all such kind of things, Oracle is best. Okay. And Microsoft SQL Server again. If you are in a Microsoft ecosystem, like using .NET, Windows Server, Azure, in such places, definitely this is a good fit to have to have it in that stack. Okay, that Microsoft .NET stack. So great integration with Microsoft tools. That is the advantage for Microsoft SQL Server. Strong BI and reporting features. Easy management with the SSMS. What is that? You can check it later. Okay. And typical use cases what are the use cases for choosing Microsoft SQL Server? Enterprise apps, data analytics, Windows based infrastructure. Right? Again, it becomes Windows based in sense like, Windows operating system. Okay. In such cases, definitely Microsoft SQL Server is best fit. Okay. Next, Amazon Aurora. You want AWS managed high performance version of MySQL or PostgreSQL. In such cases, Amazon Aurora is best fit. And you can have all that engines inside that Amazon RDS and Aurora service. If you want it, I'll show you that now. Just after in few minutes, we are going to see that. And what are the key strengths here? So here it is auto scaling and then fault tolerant, 5x faster than MySQL, 3x faster than PostgreSQL, compatible with the AWS ecosystem. So that is the advantage with Amazon Aurora. And it is a cloud native enterprise system. SaaS, e-commerce, and data heavy applications can use this Amazon Aurora. Okay, Aurora database. Understood now? And finally, MariaDB. If you need a drop-in replacement for MySQL with some performance improvements, okay, in such cases, choose MariaDB. It's open source, better licensing terms, high compatibility with MySQL. So that is the advantage. And same as MySQL use cases. When you look at the use cases, it's same as MySQL and it supports web apps, wherever we need some basic web apps or e-commerce and open source project. In such cases, we can prefer MariaDB. So this slide overall gives you an idea when to choose which kind of database. I try to patiently walk over all these points so that that gives you a clear idea for you. Because I am doing this because someone yesterday asked me, so that I just want that detailing for all of you. So we have all this in the discussion. Now, finally, quick selection guide. Small or medium web applications, choose MySQL or MariaDB. Data heavy analytics or complex queries, choose PostgreSQL or Aurora PostgreSQL. So any one of these. Enterprise grade systems with complex transactions, choose Oracle or SQL Server. Cloud native apps on AWS needing high performance, then choose Aurora, MySQL or PostgreSQL. Windows plus .NET environment, choose SQL Server. Open source with advanced features, GIS, JSON-B or CTEs. Okay, in such cases, prefer PostgreSQL. So this overall, all these slides are going to give us a very detailed picture of what is that. It will answer many of our questions. What is the difference between SQL and NoSQL? What is SQL? What is NoSQL? And when to choose SQL, when to choose NoSQL. Again, inside SQL, which kind of SQL database I should choose? What are the different parameters that exist? Okay. And then finally, we have a quick selection guide. So this gives you a quick idea when should you choose MySQL or MariaDB or data heavy analytics or complex queries, when to choose Postgre or all these other databases, relational databases. So, so with this, I think I try to give you a very detailed this thing of what is that about databases, a quick walkthrough about different databases, and a quick intro about SQL versus NoSQL, and then what is how SQL is, when SQL is used, and what is NoSQL, and when to use NoSQL, all that. So this 1 hour session or this 15-minute session is going to cover up all those scenarios, and that will help you to answer even any of such questions exist in interview. Okay. So is this clear for all of you friends? Understood now? Harish or Ajay or okay. Simha, all of you.
Yeah.
I know I took some time today so that you get a clear idea on this. Now coming to now we are going to jump into the cloud database. Okay, that too we are going to talk about cloud services. So in Amazon, so let me just open Paint. So somebody pinged me some question or what? Okay. So let's start it. Let me use a Paint here. So in this thing, in AWS, you know, right? What is AWS? It's collection of services, right? There are so many services in AWS. Let me just, you know, right? AWS services. Now this today's topic is about connecting to databases, both relational and non-relational. For that in AWS, we have two types of services. What is that? Amazon RDS and Aurora. So this is the service we have. I'll show you in AWS account. Soon I am going to jump into the AWS console. We see all these services. Second one is DynamoDB. Okay, what is that? DynamoDB. So what is the purpose of Amazon RDS and Aurora service? So this one helps us to connect it to all relational databases. Okay, all in sense there will be some selected database engines which are very popular, which are that is needed in industry. So all those are grouped into this service. All those are added to the Amazon RDS and Aurora service. So this service helps us to set up a relational database. Okay, to set up relational and manage that relational databases. So that is this service. And DynamoDB is a NoSQL database, right? And this is a service come and we can use it as a database itself. Okay, so we don't have again this thing. This itself is a database, and that helps us to create a NoSQL, set up a NoSQL DynamoDB in AWS environment. So this is overall a quick idea about two services that are used in AWS. Now, let me open the AWS console now. You can see this now, right? So now let me show you. Already I am into that. You can, if anyone is new to this AWS, let me just quickly show you. So I'm going to the home page. Okay, you can see services. Click on services. Or if not, you can do one thing. You can just type anything you can type here, friends. You don't need to directly see anything. If you want to see something, you can come here and click on this service. It shows you all that list of services here. So this is showing something, not this. Okay, so you can click here. Otherwise, you can see this. This is the landing. It shows you all that different things available under AWS, and click on all services. You can see here, view all services. And this gives you list of all services that are present inside AWS cloud this thing environment or cloud infrastructure. Okay, this is AWS environment. And here, suppose I want to connect it to a database, right? Especially a relational database. What database? Relational. Then you can see somewhere here that database, this thing is there, and these are different. You can see here there are different services available to connect to different database related this thing. Okay, so now if I want to set up any relational database, then I can choose this. You can see here. What is that? Aurora and RDS. This is the service. Click on it.
Hi Manohar, can I
Yeah.
please plug into charging? Your laptop is going to die.
Oh, is it? Sorry. Thanks for reminder, Ankonda.
Okay, most welcome.
Okay. Okay. Thank you, Simha. Okay. So I think now we are good, right? Yeah. So when you come here, Aurora and RDS, you can see here. This is the place where we can create our databases, right? Suppose you can see this. This is the button here. If you want to start creating a database, you can say that create database. Now we are going to explore this service. What is that? Aurora and RDS. We are going to create a relational database and then set it up and then just create some table and then create database and table and then insert data and just do some selection. And that gives you an end-to-end idea about how to set up a database into this AWS environment. And then how you can manage that database. We can see all that here. Okay, that is what we are going to do now. That is step 4. Databases. The learning objective is overview of this AWS databases. Right, we have for that, what is that? To set it up relational databases, we have Amazon RDS, Aurora and RDS. That is slightly modified now. Earlier it is Amazon RDS, now it is Amazon Aurora and RDS. Okay, and for in-memory non-relational, we have DynamoDB. Today we are going to cover, maybe we are going to see both. How to create a relational database and just test it. How to create a NoSQL database and test it. We are going to do that in today's session. And for in-memory caching, there is called Elastic Cache. For data warehouse, there is something called Redshift. And for graph databases, we have Neptune or Aurora serverless. But today our focus is on these two topics. What is that? Our topics is on relational databases and NoSQL databases, that is DynamoDB. So I'm going to proceed with that. Next after that, the core concepts is what is Amazon RDS. So far I had discussed that. What is that? I have clearly explained what is that Amazon RDS is. Inside Amazon, there are different AWS services, right? Inside AWS environment or ecosystem. We can call this as ecosystem. Under that, there are many services. And to connect it to this relational database, one such service is Amazon Aurora and RDS. Of course, I just flipped it, but actually the actual name is Aurora and RDS. And this service helps us to connect to relational databases. Right? We have a couple of relational database engines under that service. While creating database, it shows us all those engines and you can pick one among all that. engines. Okay, so we don't need to worry about it. So that's what this is. Okay, and then so other things we can just ignore for now. Now I'm going to these are the hands-on steps we are going to implement to test this. These are the lab steps we are following now. I'll just directly show you how to do that. You don't need to go through this slide. You can watch it from the Amazon AWS console. How to create a database, what are the different parameters we should choose to create a database. And then once that is done, we create a small database and test it inside this. Okay. So now if you want to create any relational database in this thing, okay, I have already created one, and not just one. I created many databases, but generally I delete it once that is done. Okay, once testing is done, I keep deleting so that we can avoid that unnecessary building. You understand, right? So now I'm creating one more just to show you for demo. So you can see here, if you want to create any database, come to this window, just type here that RDS. Under that, you can see Aurora and RDS. Right, you can see it shows that managed relational database service. When you click on it, you go to that window. And from here, we can create set up our SQL databases. Okay, relational databases. Now you can see here, when you just come to this landing page, in that you can see this button, create button, click on it. And you don't need to do anything, choose standard create, and then come here. These are the engine options you have. You have Aurora MySQL, Aurora PostgreSQL, MySQL, again normal MySQL, and then normal PostgreSQL, MariaDB, Oracle, MySQL, Microsoft SQL Server, IBM DB2. Okay, these are all popular database engines that exist in real time. So you can choose any one of these. But for our demo purpose, I am choosing MySQL, which is simple and my open source. Okay. And now you can choose the ones that is done. Most of these are auto selected. You can just leave them as is. Most of the features or parameters are by default selected. You can see here addition MySQL community, it is automatically selected. And the engine version, anything above 8 plus should be fine. MySQL 8 plus should be fine. 8.0 something, you can see there are so many here. So you can see 8.4, all that, but this should be fine. 8.0 is fine. 0.42 is fine. And remaining things, so that you can just leave it as is and then choose free tier here. Don't go for production or dev test if you are learning or doing a quick testing. If you are working in any real time, then you based on anyhow, you know that what kind of machine you need to set up. So that requirement will be very clear in the document. So based on that, you create a production or dev or test test database. But here I am choosing free tier for this learning environment, learning demo. Okay. And then the rest of the things are auto selected. That just leave them as is. Okay, you can see here. So once you choose free tier, availability and durability, that is auto selected. It is a single agent DB instance deployment. You can just leave it like that. You don't need to make any changes there. And just change here database name. The database name you can give it as, I'm just giving it as for now, NoSQL. Okay, you can see here. I just give it as the SQL test DB. Okay, I'm just naming like that. You can give some meaningful name if you think you have anything there. Okay, this is the, and we can just change this database instance DB instance identifier. Okay, you can name it as NoSQL. Here I am naming as this. Okay, you can just give some meaningful name here. Once that is done, scroll down a bit here, here it should be this. You can just leave it as admin itself. No need to make any changes there. And for self-managed, you can see here you have credential management. You have two types. You can choose self-managed, and here just provide the master password. Don't choose auto-generated. Somehow this is not working for my tribe, but it's okay. You can explore it if you want. But for now, I'm going with providing master password. So choose master password. Anyhow, having password is always good. So you can proceed with this password option. Okay. I just gave one simple password just for testing purpose. Anyhow, after that, I'm going to again remove this or terminate this DB instance. So this is just only for a temporary purpose or demo purpose. Okay, I just provided, and here just provide that password. Once that is done, and you can choose burst classes. This we have two different burst classes available. One is db.t3 and db.t4. So this has something about CPU's information, RAM information, all that. So you can choose any one of these two options. Okay, I choose db.t3 instead of db.t4. Okay, so that should be fine, right? And storage, you can leave it as is. Okay, so you can just leave it general purpose SSD GP2. If you want, you can expand and see other available options, but this should be okay for us. And allocated storage 20. And then we don't have, we are not connecting with any EC2 instance as of now to this this database, right? Or MySQL database. So you can just choose this option. You can leave this as is. Don't connect to EC2 compute resource. And also virtual private cloud. This also you can just leave it default. You don't need to make any changes. Okay, next after that, DB subnet group. Okay, so yeah, you can leave this default. You don't need to make any change. And then public, change this access. Public access by default it is set to no. Just reset it to yes. Okay, and then also what is that? So creating what VPC virtual private cloud security group. So we have to create this security group, friends, or you can choose existing one. I have existing security groups. I don't have a problem. Okay, if I just click on it, I think I am in some different location. That's why it's not showing security group. It's in Europe. Actually, I created under Virginia. Okay, so there we don't have a big issue. You can create anywhere in any of these regions, but better if you create it in Virginia region. Okay, because these are all different regions available. And if you want, you can create in any region. But usually go with all the first four options. So those regions are most preferred regions, and then just try to use any one of these four or something near to your location. Okay, for us near to our location is Mumbai. You can choose that. Okay, it's up to you, but I'm going with Virginia location. And then now I'm just quickly going through the steps again. You can see I just created standard. I choose standard and create and MySQL, and then because I know what to change quickly, I'm just going a little bit fast now. Free type, and then database name, I'm choosing it as NoSQL. So SQL, I can just say hyphen SQL hyphen test hyphen DB. Okay, next after that admin, I just left keep that as is, no change for that. Just keep this admin only. And then here just provide a password. Okay, make sure you remember that password or keep it somewhere. Of course, if you forget, nothing happens. You can modify it later if you want. Admin 123. Okay, I'm spelling out as well. It's okay. I'll soon delete this instance once we test everything and once we are good with all our learning. Okay. So finally, I created password and rest of the other things. If you want this, I'm choosing T3 and storage, you can just leave it as is, no change with that. Connectivity also, you can just leave it as is. And then this public access, change it to S instead of no, so that you can access it even outside the cloud environment. Okay. So then after that, VPC security group. Generally, now you can see I created many security groups in this region. If you want, you can reuse it. Suppose you are new and if you want to see how to create it, just choose create new and then just say nomtech, okay, SQL sec grp. I just put it like this. So I just created a new group. To this, I'm going to just add few inbound and outbound security rules. I'll show you how to do that. And availability zone. Once you create this security group and you can just choose availability zone. I'm choosing US East 1B, 1A, sorry. You can choose any one of these. It's up to you. I choose 1A. And then remaining things, you can just leave it to default. You don't need to make any changes. Okay, just leave it default. That should be fine. So these are the quick changes you have to make while creating database. And here I'm choosing MySQL because for my requirement, a basic SQL is enough and MySQL is the basic one and open source. Okay. And finally, what I want to do. So other things, I can just leave them as is. So database authentication, it by default, it is chosen as password authentication. And other things also, you can just leave it to default. No more changes needed. And finally, what you have to do, create database. Just remember your username for MySQL and then password of MySQL. It just takes 1 or 2 minutes. Just give 1 or 2 minutes for that. So automatically it creates that database instance. Understood now? So this is DB identifier, your database identifier name here. Okay, when you expand it, you can see all different options here. You can see that. So configuration details here. So connectivity and security. And this, it still has to create endpoint. This is very important for us. If you want to connect it to your database from anywhere, right? So this endpoint is very important. Understood now? And then this is the availability zone you choose, and this is the security groups you created. Okay. And remaining all, you can explore all these different parameters as well. For monitoring purpose, you can click here and you can check here. We can use CloudWatch for monitoring. It's a monitoring tool for monitoring your database instances. Okay. If you want, you can add it to this monitoring, but for now, we are just leaving it as is. We are not adding anything to CloudWatch, but later we'll do that. I'll show you one complete session. We will dedicate 1 or 2 sessions. We'll dedicate for CloudWatch. Monitoring is also very important area of AWS, and definitely people ask questions in interviews. So it's just, I think, in the process of creating, it will take a couple of minutes, 1 or 2 minutes. Just leave it few minutes there. So meanwhile, do you have any questions till what we had discussed so far? Any questions, friends? No questions? Should be okay. If you have anything, just let me know. You can ping in the chat, or maybe we can also ask at the end of our session. Okay. It's still in progress. It's creating. Let me refresh it one more time. It's still creating. Meanwhile, we can do one thing. We can set it up this security groups. Okay. So to set up security group, what is that we set up in the security group? Just click on that. You can just go back again if you want to know that. Okay, go back. You can see here, right? You can come to the databases and choose your database and then click on that database. And you come here under connectivity and security, you can find this security group. And we created just now, and click on that. When you click on it, it will take you to the security groups window and click on that group ID. When you click on that, it will take you to this again next window, subsequent window. Here, you just need to do one thing. So it set this MySQL security group here, and it set a rule for MySQL for connecting to the MySQL. Similarly, we can add 2 more. What is that? Suppose I want to use SSH connection. That is one thing generally we add to the security groups, connecting via SSH. I just choose SSH, automatically it will pick up this protocol and then that port. And here you can choose IPv4. By default, you can choose this source as IPv4, and then that is one thing. Next, I add one more rule, and again add HTTP as another rule here. So if you want to do any connection to this, any website or anything from AWS, this HTTP is going to, this group helps us. And this rule helps us for connecting as a HTTP through HTTP protocol. And then here also you can choose custom thing, any IPv4, and then save rules. So you can add those two just for this thing for future use into this security group. Once you create a security group, you can reuse it for any other purpose as well. It's not like it should only be used for MySQL, this thing, database setup or anything. It can be used, or you can choose it for when you create any EC2 instance or when you do any such kind of activity. So security groups can be reused so that you can add whatever rules you want to that security groups. Rules instance, you want to connect it to what kind of protocols. You can see here, I choose HTTP, SSH, and for MySQL, we choose this. What is that? TCP with the 3306 port. Okay, and these are default ports which are assigned to these protocols. All of you are clear? So that is the idea, friends. Now go to the, we set up security groups as well. So we are good now. Now finally, what should I do? I have to go to database. I'm going back again in the same order. Of course, we can search and go to the, you can see this, go to that service window, Aurora and RDS service window. I think by now database would be created. Usually it creates by now. You can see here it's saying something like backing. It's still in the process, backing up. So just give a couple of 1 or 2 minutes. This will be, we should see available here. If status is available, then we can start using this database, right? So with this database setup is completed. The next step is connecting to this database. Okay, so what is that?
Manohar, I just want to ask, only we have set it up the inbound process. How about the outbound process?
So that we set up outbound, right? Just now, let me just show you. Actually, we can discuss that in some other, I mean, this thing, Nana. Okay, why? Because we have already discussed that in detail in our previous this thing sessions. Okay.
I'm sorry. I'm sorry.
What we do is first we will complete this setting up this database, SQL and NoSQL databases, and testing them. Again, if you want, I'll revisit that scenario, Gnana. Is that okay?
No worries, Manohar. I thought
Yeah.
creating you haven't touched the outbound. That's the reason I.
No. Let
But
us
it's
go to
okay.
the, see. You can see here. Let me show you. So go to the that particular security group, and then you can see you can you can see that I added inbound group. I mean, sorry, inbound rules here. So this is generally what we need. Okay, outbound rules. So where is that? You mean
Yeah,
this
next
one,
step.
right?
Yeah.
Yeah. This thing we will check it again, Gnana. Is that okay?
No worries. No worries, Manohar.
For our need for connecting from outside of AWS, generally we need to set it up inbound rules. Understood now?
Yes, Manohar. Thank you, Manohar.
Okay. Yeah. Okay. Where am I? Let me go to that again. And then database, it should show us available. Yes, now it's showing available. Now database is set up properly and it is 100% ready to use. So now for quick testing, what do? We don't do anything. We just connect. So all these steps are clear for all of you friends. And thank you so much, Gnana, for asking a question. Okay.
Thank you.
So because I generally feel more live when someone is asking questions. Yeah. Now, so is this fine, right? Let's do one thing. Let's test this. Let's connect it to this database and let's see how to connect it. Now I am just using a easiest way. And later on, I'll show you different ways of connecting to database, maybe next week. Okay. That's going to give you a lot of idea of different ways, like, that helps you even to even target interviews as well. Of course, most of our sessions helps that even to connect with automations, to connect these databases with automations, Boto3 automation, all that. So for now, we are going to connect with a simple source called Cloud Shell. Okay, I'm just showing you. I put it somewhere. Okay. So you can see here. So the easiest way to test that setup, that MySQL setup is, let us connect to that MySQL using this Cloud Shell. Cloud Shell is something which is present inside the AWS ecosystem itself. So if you don't want to install anything locally, like Amazon, that AWS CLI command line interface, or if you don't want to use any automation from outside, right? This is the quick and easiest way of testing your setup or installation. So now go to that AWS, just type here AWS clouds. And one thing is, before I move to that, one important thing, if I should connect it to this MySQL, just you can do one thing, select this database and click on that database identifier. You need this endpoint. What is that? How can I connect to this MySQL database? If I should connect it, this endpoint is must. And through this endpoint, we connected this MySQL database. Okay. So if you see here, so let's open Cloud Shell. Now I put it somewhere in a notepad for easy usage. So let me put it in notepad for our this thing. You can see here. So now this is the endpoint. Of course, this endpoint, this got already killed, so we cannot use it again. So now what do? This is the latest endpoint and the live available endpoint for MySQL database. Okay. So what I do, I need to connect to Cloud Shell. So now click on Cloud Shell now. So you can see Cloud Shell. You can just type in so that it shows that this is the Cloud Shell. This is nothing but a command line interface from within the AWS ecosystem. Okay, if you ask me what is this? Command line interface within AWS ecosystem. Now, what is that? How do I connect it to MySQL from Cloud Shell? This is the syntax. So you have to follow this instruction, MySQL. So you can see the command here, choose this command, just and prepare that command properly, and then just insert here and then test it. Okay, add here and test it. So what do you do right now? Go come here and then press here. Okay, add it here, copy this. Instead of RDS endpoint, just replace that with our actual RDS endpoint. And rest of the things here, instead of username, right, while creating MySQL database, we have just used that, kept that username admin. And that admin I just mentioned to just leave it as is. So username is admin here. Just replace that username with admin. And -p, just leave it as is. It will prompt us to enter password. We enter once it asks us to enter password. So this is how you have to prepare your SQL command. I mean MySQL command to connect it to MySQL database. What is that? MySQL, and then that endpoint, and then that again you can see here that port 3306, and then user U means admin, and then password -p means nothing but the password you have to add. So what you can do, you got it right. If you ask me what is this each parameter, -h represents you are trying to add endpoint, the connection endpoint to MySQL. -p represents port here, which is by default MySQL always runs on 3306 port. And then -u represents username, which is nothing but admin. -password represents password, which generally we can pass it after that password, or you can enter it once it prompts you after inserting this command or running this command. Copy this command, come to the Cloud Shell, and then try to insert here. Okay, and then press enter. And it asks you password. We just need to enter that password we created at the time of creating the database. Okay, so what you do is I'm just adding my password and enter. Okay, I just entered my password and then also entered after that. I think it's checking that password here. It has to give something, a prompt or error or something. So generally it doesn't take much time. Okay, again, let me add admin. Boto3 and enter. By default, it should by now it should connect to the this thing.
The database. Manohar, actually, we have to enable the inbound port MySQL dump in the inbound.
Oh, is it? Okay, let me
Yeah,
just go there.
three
Okay.
three 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 zero six. Because of that only the error is popping up. I think so.
Okay, let me check. Maybe I didn't see it. So this is already enabled, right? Inbound role. You can see it, right?
Yes. Okay.
So
But
we
it
set
is
it. Okay,
custom.
okay.
Can it work anywhere?
Yeah, actually, we have to set either to custom IP or IPv4 or yeah, I did set up with this. I think this should be same.
The downer
Not
one, I
this.
think.
Sorry,
The
sorry, sorry. Actually, yeah. I think this
yeah.
is HTTP. Yeah,
Yes.
this is all okay. This is set to custom. Okay, I think we have
Yeah.
to set it to IPv4.
Yeah.
This
Yes.
should be the issue actually. Okay.
Yes.
Yeah, I understand now.
Save.
Yeah, I do that now.
Thank you, Manohar.
Yeah, I got that. Let us test it now in Cloud Shell. Actually, it has to run here itself when we run this command. Once installation is successful, okay, let us do this testing here. Paste it here. Press enter. Admin 2, 3, 4. Yeah, thank you. You saved my life. Okay.
No, Manohar, I was just going through. Thank you so much for your help. Because when error is coming, we find some other option. Like in case if your error is not coming, we don't. Okay, it's working. Okay, we will not go and check any other thing.
Yeah, that's
It's good
actually
that error is coming.
correct. I got definitely it is very helpful so that next time we see that this is another thing where we need to do a check. Okay, it helps me as well. Yeah, I was thinking I didn't see that. Usually, what happens is when you go to security, we will for sure we will choose this IPv4. You can see that every time I set up, you can see edit rules. So I generally pick up this IPv4, but only for this time it is by default set to something else. That's why it's throwing error. Maybe this one. That's why it's not allowing us to access. So the reason is that now, yeah, we should be good right now. There is no change. That's fine. And finally, we are successful. Actually, this database, you can see now we are able to connect. Let me just run few queries here. Okay. So you can just say show databases and then it shows databases. And then if you want, you can create database, something like nom underscore the DB just for testing and then semicolon. Okay, it created. Again, you can say show databases. Okay, and you can say use nom underscore DB, right? Now this itself shows that we are successful. So we are able to connect to database successfully, that MySQL database, and then we created a custom database, and then we can also create table here. Let me just run those queries. I just put few queries here. So where are the queries? Just to avoid this errors, all that, I just added this thing. Okay, create table students. Okay, let me add this query here. Okay, yeah, perfect. Let's enter. So and press enter. Table is created. So if you say show tables, thanks for that, Gnana. It's helped a lot now.
Thank you.
Actually,
You are welcome.
I was looking on different things, only a small issue because most of the time I created it worked. Only this time, of course, it's a good learning as well. So now let's add that this one and then paste it here and then enter. It created record as well. And finally, we'll run last query here. You can see that and then test it. enter, okay, and then paste it here. That's perfect. Okay, so finally we are able to set it up. What is that, friends? So our RD relational
RDS
database.
database.
Okay, relational database successfully, and then we are able to even test it in Cloud Shell. So this is a tool inside AWS environment where we can. I don't think we need to install all this as well. This is unnecessary, but I don't say unnecessary. It's a workaround we did to make sure that we connect to the this thing. But the issue is not with anywhere, but only small change we can do here. Okay, fine. That is one part. So this is all about that other things like, connecting to the databases. Maybe you can just say RDBS, RDS, sorry. So you can check here. So this is the database we have. And now we are able to test it successfully. So we are done with this clearly. So next part is I have to jump to, I am not today, of course, next week we'll take it up. Actually, the idea is to connect it to this DynamoDB and then to test all that different steps associated with DynamoDB. But it's okay. A couple of minutes have been, we have been missed out on this R&D. Yeah. So here the automation part, simple, friends. Actually, we have to add this MySQL connector. For some reason, this is struggling actually. Package installed successfully. If it is installed, it should not show this error. And you can do one thing, refresh it. Maybe we can also do one thing from here. There is a refresh option to run the automation from the Python itself. Generally, I do a lot of automations. You can see on the AWS. We did so many. For testing, why this is not, we already added. For my SQ, again, it's not coming. Not sure why. We did install, right? Even in settings, we have it. We have MySQL here in place. Let me check here. Add MySQL. And that is already in place, right? Install package. I am doing it again just for one more time. So let's close it. And now let's try to import it again. Oh my, yes. No, it should show us actually. There is some issue here. I think we can also do one thing. The one option is restarting this thing. Otherwise, is there a refresh option for this? We have refresh. Identifier expected. Okay, that anyhow we can fix it. MySQL dot connector. Okay. No modules one. Okay. I'll check on this. Not a big issue because usually we have to install this package. When we install, we can run the script. It will automatically what it does is it creates the database we are creating. Only missing why it's not is we have to restart either. One more thing is one option is let me do one thing. Sometimes restarting is the best choice. I'll do one thing. I'll close this. Don't ask. Exit. Yeah. Do you have anything, Nana? Any
Is there
thing?
is there any package called as MySQL connector package? The name itself, I'm not sure because I'm not well versed in Python. So I'm
No,
just
actually,
asking.
no. This is the one. The MySQL itself is the package. I think you can see here. Okay. I think I am looking for wrong one. We need to install this. Okay. So
Yeah.
install MySQL connector Python. So let's do one thing then. Let's open PyCharm now. Let it open. I'll show you what to do now. If you run this, I think I didn't see this statement. Okay. I was just going all that. this connector should be added, without which we cannot work. Okay. So copy this. You can run from command line as well. I'll show you. And I'll also show you how to run an automation on this. Of course, it is AI assisted itself. I didn't do much, but it helps you how to connect to it, connect it to AWS and test your database this thing. Okay, that should be fine for us. Okay, so click on that. Let's load the project. Okay, so core concepts, and then go to the RDS MySQL instance.py. Okay, we have to install connector. I think now the error is gone. If you see here, okay, it's not showing any error. Okay, still the error is there, not an issue. So to fix this, important thing is we have to install not this MySQL. Go to the file settings and then choose interpreter. Okay, project Python interpreter. And then you don't have that connector. Generally for each database we have a connector. So important thing is choose this MySQL connector Python. Come here. Add that. You can see this is the one we should install. Install that package. So this is missing. Okay, close it. And then finally you have that connector. This time it will work. You can see that error is gone. Understood now? So thanks for again one more heads up this thing. See,
Thank you.
actually I'm checking for MySQL as per the AI itself, not AI. As per the steps, I should install the connector. So that is missing. I thought that is there, not an issue. So now we can run this now, and the database name is what is that it is using DB. That is not there. I created DB. Let me run this automation now, and this should work now. And you can see that endpoint it is able to catch the endpoint connected to MySQL successfully. And then all the steps ran very well. Now you can go and check in the database here. This is an automation, right? Where can we check the databases? So to check that, the best thing is we have output here itself. It is showing clearly inserted 3 records and then this thing. So if you want to verify it, you can verify from the Cloud Shell. Now you can do one thing. You can say exit here. When you exit, you come out of that thing. We come out of database itself. Yeah, okay. Let's insert it to the get into that again. And then admin 1, 2, 3, 4. Okay. And then show databases. I'll just show you. Okay. And then you can see there DB is created from the automation. Can you see that? Now you can see that and then paste it here. Not connected. DB and then enter. So there should be we can see that. Now we can say show table and then enter. And you can see that again students table is created from here. So select, we can apply a select query here, start from students from that database. Okay. And you can see that the records inserted from this is through automation. You got it right?
So Manavji, basically what you did in this automation, you have created a database. You have after creating a database, you have inserted the table inside one table.
Okay.
So that's it. And apart from that, you have used the RDS endpoint input directly, like username and password has been given directly.
Yeah, let me come step by step here, Gnana. So you can see here, right? So this is the first step to connect it to any kind of service. If it is RDS or if it is, we use this Boto3 client. So now we are connecting to RDS and the region we are specifying here. And then this particular code gets the endpoint. You got it right. This is our database name and the response. When you say that that you can see here RDS dot identifier, and here we are passing to this method as our database name, so that it will fetch the endpoint for our database. Okay, you can see that it gets the response. From that response, we are choosing the endpoint. So this particular code block connects to the database and gets the endpoint from the database. That is this step is doing. Is this clear?
Yes.
Then these are credentials which we need to pass. I just prepared it here. Generally, these should be inside a kind of what shall I say? In real time, we create this config files. Okay, so that we don't directly, these are not visible outside directly. Is that okay, Gnana?
Yes.
Okay, and then after that, and then now this is connector. So connecting to the database where you have to pass host as endpoint and then username and password. Whatever we have created that you should pass here, set it here. You got it? So this particular thing is going to connect to MySQL. And then cursor thing, we need to get cursor if you want to run any commands on the database. That's what this method is doing. You can see, right? When you connect to MySQL, that MySQL will return a connector object to MySQL database in the AWS. You got it, Gnana? So on top of that, you are applying a cursor method that returns cursor for the MySQL database. And using this cursor object, you can run all these SQL queries. You can see cursor.execute. You created a database and then you just shifted or changed that database. Okay. Okay. You switched the database with the same cursor command. And then that is directly choosing the database. Next, after step to create table with the same cursor, you apply execute method. You can see here for all this, you directly apply a method execute from that MySQL thing. Okay, cursor. Okay. And you don't need to do it. Just cursor dot execute is the method which you just place all your SQL queries that will automatically run those SQL queries. Is that okay? Now you are trying to create a table. This is straightforward. I don't think you already, most of us are familiar with queries. Okay. And then that creates table. And then you just prepared query records here like this. If you want, you can do this. Otherwise, you can directly insert records into the table. You know, right, how to do that.
Yeah.
Okay. So this is insertion. Again, same process. So as you are inserting many records, you choose execute many. There you can also use one execute to insert one, or execute many helps us to insert multiple records into the database. Is that clear, Gnana?
Yes.
And finally, connection dot commit means so that all your changes are permanently updated in the database. And finally, records are successfully inserted, and you are just applying a select command from the database. You are seeing the output here. You can see here, right, Gnana?
Yeah.
So this output is something which are already created in the database, where you don't need to go to the database and check that. Actually, I did, to show you that how we can use Cloud Shell. You can see I had again log into Cloud Shell, switched my database, and then ran that select query and showed you the database, all that, just as a proof of this thing. Okay, automation. Now, same thing, you can test it here itself if you really inserted data into the database or not. And if you that cursor dot execute will return what is that? It return that result set object, what we call technically. On that cursor, if you apply fetch all, it returns a result set or rows object. And if you iterate it, you can see all your data that is returned from the database. You can see here, right, Gnana? Understood?
Okay. Yeah.
So this is all the automation is doing. Understood now? And we can work on different automations. Okay. Generally, it's not just only connecting for that. Or from here onwards, from now onwards, what you can do, you can just get that endpoint, connect to the database. Anything if you want to make on database, until this, it is common. These steps are common everywhere. But if you want to do anything else, like suppose if you want to do insert or update or delete or anything, then you can create separate methods for each of these process, Gnana. Understood now? So that is the idea of automation thing. Actually, we had so many. Generally, we created automation for connecting to IAM and then listing out users. I explained all this. Okay, but today we just have shortage of time. I thought we can discuss this in next week. But anyhow, the idea is we want to focus more on connecting through automations itself. That's why you can see for each and every service, we try to have one automation and see that. Okay. So any
Sure.
more questions? Any more questions from anyone? And I hope all of you, thanks for your time and patience.
Also, thank
Okay.
you so much for the time change, Manohar ji, because I were able to
Okay.
join.
Yeah,
Thank you.
I am more than happy, Gnana, because for me, if we have just one or two people who are seriously interested, that gives me more energy. So here most
The
of,
only
yeah,
problem with me is like we are under time pressure and time concern is more here.